In this tutorial, we're going to take a look at the solutions to a test review. If you're actually taking my advanced functions course, this is the test review for the Unit 1 Polynomials test. And so first of all, then we'll start with multiple choice. Ask which of the following is a polynomial function? And C is the correct answer here. Polynomials have all the x's, or whatever your independent variable is, have exponents that are positive whole numbers. So 5, 3, there'd be a 1 here. It's okay to have a constant term, but you can't have any negative exponents, fractions, decimals, radicals, that kind of thing. B is a polynomial over a polynomial. The x plus 5 is a polynomial, and so is the x cubed minus 2x squared plus 9x. And that would be a rational function. E is a trig function because of the sign. D is actually an exponential function because of the x in the 7x plus 2 in the exponent here. And A here, the negative 5x and the 3 are okay. If that was all there was, then it actually would be a simple polynomial. But this term isn't, because, my pen going here, because of this root here. See, there's actually a 2 right there. And so if we were to write that term as a power, it would be 7x to the power of 3 halves. 3 halves, 1.5, so that is not a whole number positive exponent. For number 2, the range of a function is, and the correct answer is D here, the entire set of function values of the dependent variable. A, the y values isn't really a very good definition. It's probably the second best one here, but it's not as good as D. First of all, it's all the y values the function's defined for. The dependent variable doesn't always have to be y. For B, the entire set of values of the independent variable the function's defined for, that would actually be the domain. And although this is actually the domain for all polynomial functions, it's certainly not the range. Number 3, what's the end behavior of the function shown? And this function starts down here in the third quadrant, ends in the fourth quadrant, so it's going from quadrant 3 to quadrant 4, so that's why A is the correct answer for number 3. Number 4, which of the following is true of polynomial functions? And A is x, and I suppose I could have put the independent variable instead, can only have whole number exponents, but that's certainly the best of the 4 definitions here. There cannot be many variables. X can have integer exponents. Well, integers can be negative. You can't have x to the power of a negative, so that's a no-no. Y can have an exponent of 2 or more. That's not the case. Y, or the dependent variable, has to have just the power of 1. Number 3, the blank row of differences for cubic functions are all the same. Cubic means x, it's normally x, but not always, to the power of 3, so that's why the third row of differences has to always be the same. Question number 6, you're asked to find the roots of this, so we take each of these 3 factors and set them equal to 0. So x, if you set that equal to 0, well, you get 0 for one of the roots. If we set x plus 4 equals to 0 and solve for x, bring the 4 over, subtract 4 from both sides, and you would get x equals negative 4. The 4x minus 7, so we set that equal to 0, and so bring the 7 over, so we would get 4x equals 7, and then we would divide both sides by 4 like this. And you see that 4 and that 4 divide out, so you end up with x equals 7 quarters. So 7 quarters, negative 4, and 0 are the roots, which is answer B. Number 7, the average rate of change of a function is, and D is the best answer here, the change in the dependent variable divided by the change in the independent variable from one point to another. The instantaneous rate is actually the B definition, how quickly the dependent variable is changing with respect to a unit change in the independent variable at a point. That's actually the instantaneous rate. Number 8, what set of numbers is illustrated at the right? Well, we have an open circle at negative 2, which means we don't include the negative 2, but we want everything above it to the right of it. So x is greater than negative 2 would be the set illustrated here. If that was a solid dot, then we would put an equal sign there and be x is greater than or equal to, but that's not what we have, so B is the correct answer for 8. For number 9, Fine. Even functions have which of the following characteristics? And A is the characteristic of an even function. F of negative x equals f of x, which means that the function values are the same for two opposite sign integers. Like f of negative 2 would be the same as f of 2. F of negative 5 would be the same as 5. F of negative 7 would be the same as f of 7. For B is actually neither even or odd. That's just one I made up for another answer. C, this is actually the odd function definition. F of negative x equals the negative of f of x. So if you take the function values of two opposites, like 2 and negative 2, they'll be opposite in sign. Number 10, which of the following graphs illustrates a cubic graph with a real zero, one real zero, plus another double zero? And that would be B here. There's a double root here because it just bounces off the axis, and then there's a real root right there. This one actually has 3 different real roots, those 3 points. This would only have one real root, and this doesn't dip down and cross the x-axis, so there's no real roots associated with that. And the same with this one. That local maximum doesn't cross the x-axis, so one real root here, and that would be it. Now in part 2, one thing I'll draw your attention to if you happen to be one of my students. I always put there will be 5 overall communication marks for part 2 of the test, and these are the questions you show work for. And so that's for showing all your work that you do to get a solution, to prove something, to show something. It's also how well you communicate mathematically. Do you use proper mathematical form? Are you using proper mathematical units? That kind of thing. So there's an overall question for anything you're showing work for. The very first question in part 2 here isn't something you show work for because you're really just writing 1, 2, 3, or 4. We're matching these 3 equations with their corresponding graph. And if you look at A and C, they're quartic functions, power 4, power 4. This is a positive quartic, and this is a negative quartic. So a positive quartic goes from quadrant 2 to 1. Kind of looks like a W. And so that's why that's number 3. A negative quartic goes from quadrant 3 to 4. So this is a negative quartic here. So that's why the 4 is associated with C. Now, B and D are odd functions, negative x to the 5th and negative 0.2x cubed. So odd, so they're going from, and they're negative odd, so they're going from quadrant 2 to 4. So really, well, which is which? Because those both go from 2 to 4. And if you look at the intercepts, the y-intercepts, this has a negative y-intercept. So this is the one that has a negative y-intercept. It goes through below the origin. So that's why 2 would have to be this one. This has a positive y-intercept, a positive 2. So if you look closely, you can see that this goes through a little bit above the origin. So that's why D would be graph number 1. Question number 2 says use the graph of the right, and of course the table is going to give you more accurate data for doing this, especially for A, to answer each of the following questions. These are Usain Bolt's, the data from his world record 9.58 second 100 meter dash, and it's still the world record as of recording this in September 2016. So for the first one, from 0 to 2.88 seconds. So notice that this gives the times for every multiple of 10 meters from 0 to 100. So 0 to 2.88 is from this point to this point, or on the graph from here to that point right there. And so average velocity is change in displacement over change in time. So the change in displacement would be from 0 to 20, so that's why I do 20 minus 0. And the change in time would be 0 to 2.88, so 2.88 minus 0. So really dividing 20 by 2.88, so the average velocity is 6.9 meters per second. In B, it says, what is his average rate at 2.88 seconds? So at a point in time, we're looking at for an instantaneous rate. So the 2.88 is right there. So I've drawn a tangent line to touch the graph just at that point right there. And I've drawn a triangle around it, a rate triangle like this. Notice the dotted lines. So that's at about 2 seconds. That's at 10. So this is 8 seconds for the change in time across the bottom. And for vertically, you see this is actually going from about 10 meters to, that would be about 90 meters. So 10 to 90 is 80 meters. So the change in displacement across that triangle is 80 meters, change in time is 8 seconds, so divide that, you get 10 meters per second. So he's going at a rate of about 10 meters per second at 2.88 seconds. Number 3, you're asked to use differences to determine the degree of the polynomial function and then also find the value of the leading coefficient. So in the first one here, we start looking at the first differences. From -4 to 3, we're going up 7. From 3 to 2, we're going down 1. 2 to -7, we're going down 9. Remember, you subtract these. You got to make sure you get the signs right. Actually, I'm going to bring my calculator over here to show this. So the next one, from the change from -7 to -24, if you're actually doing this in the calculator, make sure you type the numbers in the correct order. So if I want to change from -7 to -24, type the -24 in first. And so, see, there's where the -17 comes in. It's a fairly common mistake here to subtract them in the wrong order, and then you would get that to be +17, and you're certainly not going to get the right answer then. From -24 to -49 goes down 25. So first differences are not the same. It's definitely not linear. So now we look at the differences from across these numbers. So from +7 to -1, it's going down 8. From -1 to -9 is going down 8. In fact, they're all down 8s, so -8s. So that means it's quadratic. The degree is 2. Now to get the leading coefficient, remember, the constant differences, which is the -8s in this case, is equal to the leading coefficient times n factorial. So in order to find what a is, I would divide out the n factorial here. So a would equal the constant differences divided by the n factorial, which is, this is really just that rearranged. Solve for a. And so the constant differences is the -8. Since it's degree 2, n would be 2, so we divide -8 by 2 factorial. -8 divided by 2 is -4. So the leading coefficient for this quadratic function would be -4. For b, for the second one, 29 to 14 is going down 15, 14 to 1 is going down 13, and you can keep on going, and the first difference is not the same, so it's not linear. -15 to -13 is going up 2, -13 to 7 is going up 20, 7 to 45 is going up 38, so second differences are not the same, so it's not quadratic. But from 2 to 20, it goes up 18, 20 to 38 goes up 18, 38 to 56 goes up 18. So the third differences are all 18, so it's cubic, which is degree 3. And so once again, to find the leading coefficient, a is the constant differences, which is the 18 in this case, divided by n factorial. So 18 divided by, and it says it's degree 3, n would be 3. 3 factorial is 3 times 2 times 1, which is 6. So divide 6 into 18 and we get 3. So leading coefficient would be 3. So let's scroll over to question 4 here. So it says determine the x-intercepts and draw a possible graph of this function. So to find the intercepts, we set each of these factors, because it's in a factored form, equal to 0. So we set 4x equal to 0 and divide out the 4, so we get 0. So it goes through at 0 here. X plus 5, we set that equal to 0. I guess you could put the square here, but you don't need to, because you're just going to take the square root and get rid of the square. So we take the 5 over, or subtract the 5, and so at x equals -5, there's a double root. And we set also the x minus 2 equal to 0. So we solve and we get x equals 2. Now, if you look at the degree 2, another one here is 3, another one here is 4, positive. Okay, so this is positive. There's no negative here to contribute a negative. So it's a positive quartic. So it will go from quadrant 2 to 1. And so it has to start up here somewhere. And there's a double root at -5. So it must just dip down and touch the axis there, come up here, cross a minimum here somewhere, and then back up through a 2. Now, this isn't a terribly accurate sketch. It looks something like this. I actually did one with my graphing calculator, and I used first of all the. Actually, I'm going to stop and show you that. So this is what the graph looks like in my graphing calculator. This actually has the same size window as this. This goes from about -12 to 14, -12 to 14 on the y-axis too. So you can see the double root here at -5, and it seems to cross, you can just barely see, it crosses at 0 and also at 2. So not a terribly good graph. What I had to do is alter the window. I left the x-axis the same, it's okay. But actually what I had to do is go y min, I think it went to -200, and the y max at 300. I think that's what I did. Yeah, and actually to make it look a little bit better, I made the scale on the y-axis 50. Actually, maybe I make it, well, I'll do 50. You'll actually see this graph here come up. So I need a lot more room on the y-axis in order to see this maximum and this minimum here. So this is just sort of a rough sketch. It shows the zeros, but it's not terribly accurate. The zeros are what are important here, though. Question number 5. Determine which of the following functions are even, odd, or neither. And the first one here, f of x equals 2x to the fourth minus 3x squared minus 4. This is an even function since all the powers of x are even. Okay, a 4 and a 2. Okay, so that makes it even. Also, you can use the definition. So here's my function here. And so I'll find f of negative x. So I'll put negative x in place of x here and here. So negative x in place here and also here. Now negative x raised to the power of 4 is the same as x to the fourth. And negative x squared, negative x raised to the power of 2 is also 3x squared. So notice you get exactly the same function. So that means it's even. That's how you use the definition to show that it's even algebraically. For b here, this would be an odd function because it's symmetrical about the origin. This part here, if you reflected 180 degrees around, it would match up completely with this here. And so that's an example of an odd function. That's what it looks like. Question number 6. We're supposed to graph this cubic function using transformations and show how the table of values changes from the parent function to f of x above. So the 2 is a vertical stretch, so the y's get multiplied by 2. So here's the y equals x cubed, or f of x equals x cubed parent function. -2 cubed is -8, -1 cubed is -1, up down to 2 cubed is 8. So that's y equals x cubed, or f of x equals x cubed. And so the stretch, we multiply the y values by -2. So these numbers get multiplied by -2 and give you those y values. Now, the -1, okay, x minus 1, is a horizontal translation of 1 unit right. So the x gets increased by 1, or have 1 added to it from this table to this table. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. So we increased all the x values by 1. The plus 3 in the end here, and I'll look at my instructions down here, is a vertical translation 3 units up. So the y gets increased by 3 in the last table. So we add 3 to all these. So -16 plus 3 is -13. -2 plus 3 is 1. 0 plus 3 is 3. 2 plus 3 is 5. And 16 plus 3 is 19. And so all of those points are plotted over here. -1, -13 down here. 0, 1 would be there. 1, 3 is that point. 2, 5 is this point here, and then 3, 19 is this one here. And so we join them together, and we see the cubic shape. On to question number 7. A baseball's height as a function of time can be modeled using this formula. H of t equals -4.9 t squared plus 28t plus 1.5. H is the height in meters and t is the time in seconds. And so in A here, we're asked to determine the average velocity between the first and second. My Word document thought that was a mistake when I repeated second, but of course those two words actually have different meanings here. So average velocity is change in height over change in time. So to go from the first to the second, second. I need to find the height at 2 seconds, the height at 1 second, and subtract them. So h of 2 would be, we put 2 in place of t here and here, which is that calculation there. And h of 1 would be when we put 1 in place of t here and here, which is what's in the square brackets here. And so remember your order of operations. So you have to square the 2 and then multiply by negative 4.9 to get the negative 19.6. 28 times 2 is 56. I'll explain in a second why I crossed the 1.5 off. 1 squared is 1 times negative 4.9 is negative 4.9. And 28 times 1, of course, is 28, 1.5 here. When I take the brackets off, all the signs here are going to change. So there's a positive 1.5 here, so it's going to be minus 1.5. So that's why I crossed those off, because those would add to 0 or subtract to 0. This would, of course, become plus 4.9 and minus 28. So negative 19.6 plus 56 plus 4.9 minus 28 works out to 13.3. And the units would be meters per second, because height is in meters and time is in seconds. Now on to question B. It says find the instantaneous velocity at 3 seconds. So we need to find or take 2 times really close to 3 seconds, and I use 3 and 2.99. If you want to use like 3 and 3.01 or even 2.99 and 3.01 or 3.02, any 2 times that are very close, just a few 100ths apart, would be good. Even a tenth apart, I suppose, like 3 and 3.01 or 2.9 and 3 is still pretty good. Okay, that would be acceptable too. But you need 2 times really close to one another. So I'm going to do h of 3 minus h of 2.99 over, and the change in time would be from 2.99 to 3, so 3 minus 2.99. So h of 3, we're going to take our formula up here and put 3 here and here. So negative 4.9 times 3 squared plus 28 times 3 plus 1.5, which is exactly what you see right here. And then h of 2.99, same idea, but of course 2.99 in place of time. And so we evaluate all of those, so that's what we get here. And again, the 1.5s, when we take the brackets off, are going to be opposites. That's why I just crossed those out. They'll subtract to 0. And so we get negative 44.1 plus 84. This would end up being, because of the double negative, plus 43.81, and then minus 83.72. And that works out to negative 0.01. Well, the time in the denominator is also 0.01. 3 minus 2.99 is 0.01, or 1/100th of a second. So that's what's in the denominator. And we divide those and we get negative 1 meters per second. Notice how close to 0 that number is. See, in B up here, the ball was rising. That's why the velocity is a fairly large positive value. It's actually, well, it's close to 0, but it just reached, it must have just before 3 seconds, reached its highest point, and now it's starting to fall. But it's just past its highest point. It's really not falling very fast at all. So that's what that negative 1 means. It's just past its highest point. It's starting to fall. So that would be the instantaneous velocity at 3 seconds. It's right around negative 1 meters per second. And that's the end of the test review.